All right, guys, let's start off here on number 2. So this one, it says one plumber charges $50 to diagnose an issue, then $20 per hour to fix it. Another does not charge to diagnose, but $30 an hour to fix. We want to write a system of equations. So both of these are going to be in y equals mx plus b form. And so the b is kind of the initial cost that you just have to pay once. So that's going to be the diagnosis cost. So for this one, it's going to be 50. Now, this one actually does not charge to diagnose. That's actually going to be plus 0. And then the slope is kind of how that changes. So this one's $20 an hour, so that's going to be 20x. And then this one is $30 an hour, so that's going to be 30x. Oh, and I already have the plus sign there. Okay. All right, so those are our two equations. This one, I would really just write it as y equals 30x. Because adding 0 doesn't change it. And so now we need to solve this by setting these equal to each other. So I get 20x plus 50 equals 30x. And so then we're going to subtract 20x from each side. And so we get 50 equals 10x, and then we'll divide by 10. So x equals 5. And then I'm going to plug that back in to find y. I can use either equation. I'll go ahead and use the blue equation here. So y equals 30 times 5. And so that's 150. And so my solution would be 5 comma 150. And then what it means in one sentence is that after 5 hours, each charge $150. So that's the price, that's the time where their price is the same. So you may have thought that this one's more expensive because of the $50 there, and before 5 hours it really is. But then at 5 hours they're exactly the same. And then after 5 hours, this one's actually cheaper. All right, next one here, same idea. We're gonna go to school by bus, and then one of these is monthly pass is $15, and then it's $1 per ride. So that's going to be 1x plus 15. Since the 15 we only have to pay once, and then the $1 we have to keep paying over and over again. And then the other one here is no initial cost, but we do have to pay 2.5 per ride. So I'm just going to say 2.5x. All right, so now I'm going to set them equal again. So 1x plus 15 equals 2.5x. I'm going to go ahead and subtract 1x from each side. So 15 equals 1.5x. So now I'm going to divide both by 1.5. Now, this is kind of tricky here, but the easy way to do this, 15 divided by 1.5, is I like to just multiply the top and the bottom by 10. So I can get rid of the decimal. So really it's 150 divided by 15. And so 150 divided by 15 will be 1 and 0. So x equals 10. All right, and then so now I need to find out y. So y, I can plug it into either equation. I'll go ahead and use that one, 2.5 times 10, and that's $25. So there you go. And so that means is that after 10 rides, each plan costs $25. All right, next up, we're just going to distribute here. So I'm going to send that in. Remember, we multiply the big numbers, and then we actually add the exponents there. So that's my first one. And then same idea here. I'm just going to remind myself that that's a 1 and a 1. So I multiply the big numbers and then add the exponents. And then this one is going to be 16, and I'll just put that x to the third there, and that's it. All right, this one, we're going to factor the common factor, which is GCF, as we learned it in our notes today. And so what we're going to do is we're just going to think of the biggest number that these can both divide by. And so I think the biggest number is a 6. Yeah, so I take out the 6, and that leaves me with 3x squared right there. And so what I do is I divide each of these terms by 6. And so that's going to be my final answer right there. You can always check this, though, by distributing it back in. So I think that's always a good idea. And so if you distribute it back in, you get 18x squared. And then this would be plus 30, which is the original question, which means that I did it right. All right, same idea here. I got to think of the biggest number that all of these divide by, and that would be 4. But in this case, actually, I also want to take out n to the second power. Since all of these I can take out n to the second power, you kind of always do the smallest exponent if you're going to take out a variable. So if I do negative 20 divided by 4, that gives me negative 5. And then for the exponents, I am technically dividing them, but that means subtracting the exponents. So that's going to be into the fourth. You can kind of think of it like I had 6 n's in that term, and then I took out 2 n's, so I had 4 n's left. Next one here, I got to divide the 16 by 4, so that's 4. And then I took out 2 n's, so I only have 1 left over. And then lastly here, this will be plus 5, is 20 divided by 4. And then I took out both of those n's, so there's no n's left. So that's going to be my answer right there. I can still check this again by distributing. And so I kind of like to do that to make sure I did it right. So if I multiply this in there, I get negative 20, and then I add the exponents. And then this one would be negative 16, and then add the exponents would be the third power, and then positive 20, and then just add that at n squared. So that does give me what I originally started with, so that is good. All right, these ones we're going to factor, and when we have 4 terms here, we always use the grouping. And so we want to group together the first 2 terms and the second 2 terms. And I'm going to GCF on each. So on this first group, I see I can take out a 3, and I can also take out x squared, and that's going to leave me with 7x plus 8. So I'm just dividing again the big numbers, and then subtracting out the exponents. So, and if you double check here, 3 times 7 is 21, x squared times x is x to the third, 3 times 8 is 24, and then that attaches the x squared right there. The second group, I see I can take out 5, so I'll go ahead and do that. So I go plus 5, and that leaves me with 7x plus 8 again. It's very good because to do the next step, these actually need to be the same, which they are, and then they combine to make their own parentheses here. And then we have another parentheses for the stuff outside, so that's going to be 3x squared plus 5. And there's our answer. We can also check this one, but I would check this one by using the box. And so we'll have 3x squared plus 5, and then 7x plus 8. And if I multiply this, I get 21x to the third, I get 35x, I get 24x squared, and then I get 40. And what you can see here is that all of these terms, this one is right there, this one is right there, this one is right there, and that one is right there. So all my terms are represented. All right, next one here, once again, we'll group these together. Now, when we have a negative in the middle there, you want to make sure you include that in the second group. So my first group, I don't think I can take out a number, but I can take out a squared, and that would leave me 3a minus 2. And then the second group here, I actually want to take out a negative 2, and that's going to turn this into positive 3a minus 2. Remember that if you divide by a negative, it actually gives you, it switches the sign there. So you can check this. A squared times 3a is 3a to the third. A squared times negative 2 is negative 2a squared. Negative 2 times 3 is negative 6a, and that gives you positive 4. All right, next up I make 2 parentheses. One's for the stuff outside, so that's a squared minus 2. And then one's for the stuff inside. So that's my answer, although I still like to check my work by multiplying them together with a box. So I got a squared minus 2, I got 3a minus 2. So I get 3a to the third minus 6a minus 2a squared, and then plus 4. So you can see that every single one of these is represented right there. And so I did it correctly. All right, next up here, we're going to multiply these together. You can either use the box or use FOIL. So I'll go ahead and use the box on this one. So I got 5n minus 5, and then I got 5n plus 5. So this will be, oh, that looks like a 6, huh? All right, let me fix that. All right, so 5n plus 5. Okay, so then I get 25n squared, negative 25n, 25n, and negative 25. So in this case, these actually cancel out here because I have one positive and one negative. So I get 25n squared minus 25. There's my answer. All right, next up here, I have 4n plus 5 squared. So on this one, I need to write it twice. So I have 4n plus 5, 4n plus 5. So on this one, I'll go ahead and show the FOIL, which is first, outer, inner, last. Remember though, you can use the box on all of these. FOIL and the box are interchangeable, but I like to show both techniques here. So first times first would be 16x squared. Actually, it's n squared. Outer times outer would be 20n. Inner times inner would be 20n. and then last times last is 25. So then we combine like terms, and we get 16n squared plus 40n plus 25, and that's our answer. All right, next up we're multiplying the So we're going to multiply the binomial times the trinomial. So I'm going to go ahead and I like to use the box for this one because there's kind of a lot of stuff going on. All right, so now we'll multiply, which means multiply the big numbers and add the exponents. Multiply the big numbers, add the exponents. Multiply the big numbers and then add the exponents. Same thing here. All right, so the next up, we will combine like terms. So 12n to the third does not have one. These two I'll combine here. So I get negative 9n to the second. And then these two are going to combine. They're both negative, so it's going to make negative 41n. And then the plus 35 has nothing to combine with. Next up, we're going to solve these. I'm going to distribute first. So negative 7b minus 35 plus 7. And then this will be negative 7b plus 4. Next up, I'll go ahead and add 7b to each side. Actually, no, before I do that, I want to combine like terms, actually. So I'll just combine this negative 35 and positive 7 will make negative 28. And then I will add 7b to each side to get all the variables to one side. Now in this case, they actually cancel. So it'll be negative 28 equals 4. So whenever all your variables cancel, it's either no solution or infinitely many solutions. This is not true that negative 28 equals 4, so this one's going to be no solutions.